Okay, now let's look at building a tree with unequal misclassification cost. Remember, we talked about this in chapter 5. Okay, not all error in classification is equal. Okay, there are some errors which are more serious, okay, involving larger costs. So we can do that using the Pond's argument, okay, in the R part. Okay, so how are we going to do that? So again, we set C for cross validation. Okay, so let's call it cost tree. R part, personal loan. Okay, so the entire using all the variables and data equal to train.df. Okay, and method equal to class. All right. Then okay, bonds equal to. Okay. So here are the rules for how you should enter. So you can have prior probabilities for the target. So you can select split based on information or Gini. Gini index is the default. But if you want to use information gain, so that is the entropy. If you want to use entropy, you can say split equal to information. Okay. So that will use entropy for you. Okay. And then loss. Loss is your cost matrix. So this should be a list. Say loss equal to. Okay. This has to be a matrix. So matrix, you need to specify how we did this long back. How to set up a matrix. So I'm going to give a vector of the values. Okay. And then I have to specify how the matrix should be built with these numbers. So I'm not saying that build a matrix with these numbers. Now, you can have a matrix of like 2 rows and 2 columns, okay, or 1 row and 4 columns, or 4 rows and 1 column. Okay, those are the possibilities with 4 numbers. If you have 6 numbers, then you will have different possibilities. So now I'm going to now say how many rows we want, or you can say how many columns we want. Okay, so n row equal to 2. Okay. Then you have to say whether you want these to be built row-wise or column-wise. Column-wise is default. If you don't say anything, so you take 0, so you go column-wise. So you go through the numbers and it will build columns. So you have 0, 1 as one column, 5, 1 as the second column. But if you say row-wise, then it will go 0, 1 as the first row, 5, 1 as the second row. Okay. So you have to decide what those numbers mean. So you say by row equal to true. Okay. And then say x val equal to 10, so that's 10 fourths. Now, what this is going to do is, remember our the way you build the matrix is, okay, you have the actual, predicted, so across the diagonal there is no misclassification, so cost should be 0 here. Okay. Now if this is how you set this up, if 1 is the positive case, then here it is, so you predict 0, then this is false negative. Okay. Actual is 0, you predict 1, this is false positive. Okay. So depending upon what those costs are, you have to make sure that the matrix is consistent with this. Okay. So the matrix we built 0, 1, 5, 0. So that means cost of false negative is 1, cost of false positive is 5. Okay. So that's up to us. We need to make sure that the way we build the matrix corresponds with what the actual costs are and how it is built. Okay, row wise or column wise, or by row or by column, things like that. So once that is done, then we can print the cost tree. Okay, so I'm missing a T matrix, and okay, so I have a, that should be 0. The diagonal must be 0. So there I have it. Okay. Now, of course, you can print the rules using rpart.rules. Okay. And then if you want to generate confusion matrix, then you have to use the cost.tree to predict and then do the confusion matrix.